Hello guys, we are just continuing the previous video. Our time elapsed. Okay, so question 7. A ball of mass 5 kg moves vertically upwards from ground level till it reaches a maximum height of 4 meters. What is the kinetic energy when it is halfway up? Assume g is equal to 10 meters per second squared. Okay. When the ball is at its maximum height, its kinetic energy is zero. When a ball is at maximum height, its kinetic energy is zero, and its potential energy is mgh, just potential energy. It's mgh, where m is the mass of the ball, g is the acceleration due to gravity, and h is the height. So the potential energy of the ball at its maximum height is going to be 5 times 10 times 4. It's going to be, let me write it down, 5 times 10 times 4, which is equivalent to 200 joules. Which is equal to 200 joules. Since energy is conserved, the total mechanical energy of the ball, it will be kinetic energy plus potential energy, remains constant throughout its motion. So when the ball is halfway up at a height of 2 meters, when it's halfway up, because we said that the height is 4 meters, so when it's halfway up, which means at the height of 2 meters, its potential energy is going to be 5. It's going to be 5 times 10 then times 2, because now it's halfway up, times 2. Then the answer will be 100 joules. The answer is going to be 100 joules. Therefore, its kinetic energy at that point must be, so we will subtract 200 minus 100, which is equivalent to 100 joules. 100 joules. So our answer is C. The answer is 100 joules. We can go to the next question. Now we are in 2010 questions. Okay. A plumber needs to measure the internal diameter of a water pipe as accurately as possible. The instrument that should be used is the vernier calipers. That's the answer. Then we have this question. Starting from rest at time t is equivalent to 0, an object moves in a straight line with a constant acceleration of 2 centimeter with a constant acceleration of 2 centimeter per second cubic. At what time is the speed of the object 20 meters per second? So the speed of the object can be calculated using the formula of speed. We can use this formula of speed. V is equal to U plus AT, where V is the final speed, U is the initial speed, A is the acceleration, and T is the time taken. Since the object starts from rest, its initial speed is 0. The acceleration is given as 2 centimeter per second per second squared, which can be converted to that acceleration. It can be converted to 0.002 meters per second cubic per second cubic. The final speed is given as 20. The final speed it is given as 20 meters per second. So we can solve for t as follows. We can just say that 20 is equivalent to 0 plus 0.02 times t. Then when we do the math, we will say that t is equivalent to 20 divided by 0.02. Then the answer is going to be 1000. 1006 seconds. So our answer is D. 1000 seconds. That's the answer. Yeah. Which property of the body cannot be changed if a force is applied to its velocity? Which property of the body cannot be changed if a force is applied to its velocity? It's mass. Mass does not change. Give the name of the force which gives a mass of 1 kilogram, 1 kg or kilogram, and acceleration of 1 meters per second squared. So the force which gives a mass of 1 kg and acceleration of 1 meter per second squared is called Newton. This is Newton. Okay. Then we have this question. A load is to be moving using a wheelbarrow. The total mass of the load and wheelbarrow is 60 kg. The gravitational field strength is 10 Newton per kg. So we have this load, the wheelbarrow. What is the size of the force needed just to lift the loaded wheelbarrow? The size of the force F needed to lift the loaded wheelbarrow can be calculated using the formula of W is equals to mg, where m is the where W is the weight, m is the mass, and g is the gravitational field strength. The total mass of the load and the wheelbarrow is given as 60 kg, and the gravitational field strength is given as 10 Newton per kg. So the weight of the loaded wheelbarrow is going to be A, 350 Newton. 350 Newton. Okay guys, again time is not with us. Soon it's going to be lap. Which of the following is not an SI unit? Which of the following is not an SI unit? Okay, let me just connect to another video again. But please don't forget to subscribe and like this video. Thanks for watching.